Oh god, a cubic polynomial in the denominator? A cubic denominator that doesn't look factorable. What on earth do I do? So whenever you come across something like this, there's one thing, there's one sneaky thing that integration bees like to do, is whenever they give you an ugly polynomial, most of the times, well, what they should do is they shouldn't give you a random polynomial, obviously, unless you're like a community college integration bee and they just give you a textbook problem. Then I'm so sorry for you. But there's a purpose. Usually, every integral has a purpose, and why this polynomial specifically is just why. Why would they give me this specific polynomial? Whenever you find a polynomial that does not look factorable or ugly, here's what you should do. Plug x equal to 1. Okay, x equals to 1 into this polynomial. Then I get 6 minus 11 plus 6 minus 1. This is negative 5 plus... Oh, wait a minute. What? Huh. Well, would you look at that? So, this is the key. Okay, the reason what this means is that x equal 1 is a root to this polynomial, which means that this is, you can factor this by x minus 1. So we're going to do synthetic division because it's a lot easier to do, it's faster to do synthetic division instead of polynomial division. So we're going to go ahead. So because 1 was our root, we're going to go ahead and start factoring this with synthetic division. Negative 1 times 1, negative 1, 5 times 5, negative 11 is negative 6. We're adding it. This is an addition, and then times 1 with this is negative 6, 0. Ah! Oh, that's crazy. Would you look at that? We have x minus 1, and we're left with x, negative x squared plus 5x minus 6? That is crazy. Huh. This is x squared minus 5x plus 6. And this is negative x minus 1. And this, we know this. We can factor this. This is x minus 2, x minus 3. What the hell? Why would they throw something so devious to us? I mean, I didn't know this. I didn't know this was equal to this. How am I supposed to know? I'm not a math Olympiad. So, here. It seems like this is just negative 2 of this. X minus 2, x minus 3. Well, okay. So, looks like, what are we going to do? Seems like we're going to do partial fractions. Now, wait a minute. There's something that I want to test out. I want to let u equal x minus 2. Why the hell why would I want to do this? Well, it's because this is now going to become u, and this is going to become what? U minus 1, and it's going to become what? U plus 1? Huh. Would this help me? If I do 1 minus u squared? Would this help me? Right, if I do 1 minus u squared plus u squared, this is going to be like what? Negative 1 over u plus u over u squared minus 1. Ah! I don't have to do partial fractions. Did you look at that? But you do have to be very careful though. So, it seems like we can have 2 times the ln of u minus a half of the ln of u squared minus 1. Okay? And now your answer is simply 2 ln of x minus 2 minus ln of, you could just go ahead and plug it in, minus 4x plus 3. And I believe this is our answer. There we go. I want to check. Is it correct? Yes, it is. Okay, awesome. So there we go. That's our answer. Okay, so it is, if you were, you can definitely solve this faster than me if you knew what this polynomial is. Oh, this is equal to this, right? But instead of doing partial fractions, because they're consecutive numbers, you can just let u equal the middle portion, because look, they're going by consecutive numbers. So you can go ahead and just, or it doesn't have to be consecutive, it could be like arithmetic sequence, right? This could be x minus 2, x minus 4, x minus 6. It would work the same way, okay? So because these constants were going by arithmetic sequence, you can take advantage of this, and bing bada boom, okay? All right, cool. Hopefully that was helpful. It's a very sneaky trick, but yeah, be careful whenever you see polynomials. Plug in x equal to 1 and see if it's if that becomes a root, because a lot of integration means they do that. They throw an ugly polynomial, but then you realize, wait a minute, 1 is a root, okay? And then you can do synthetic division, and that falls apart very easily, okay? All right, I'll see you guys in the next video.